Good evening and welcome everybody. This is Obi-Wan Pez for Simplex Pachinko. We're off and doing some math tonight, so if anybody is interested in hearing anything about any particular math topics, if you are wanting to expand your understanding or just generally work on some sort of like homework or anything like that, this could be your place. So good evening. Hope everything's been going pretty nicely today. And, yeah, we're gonna get rid of some of the stuff that's on the boards. These were from last night's differential equations class. A sensation. You know, I don't even know. It's just whatever. There used to be a reset command here. It's whatever Pretzel Rocks came up with. So they had some kind of... Okay. Oh, because it's still technically shared. Yeah, let's stop the shared session. There we go. Reset the canvas. But yes, it is a very nice reel. Yeah, or an attempt. Fair enough. It is currently set for... Let's see what the actual setting is. Surprise me. Yep, so roll the dice. A lot of the other top played stations, I believe, are paywalled, so I can't get to a lot of them anymore. I had been interested in just like the lo-fi or chili DM or something like that, and yeah, a lot of them are now paywalled. So, surprise me, it is. Yeah, there are other like labels or artists that you could individually select. Looks like D&D is its own category, and is also free. There's a bunch. Most of which have terrible AI art as their splash. Yay. Buy more hard drives? I mean, I've already got, what, a terabyte that I'm not using most of? I think I've got 800 gigs left. 400 in each partition. Let's see. We're working on a couple of these last time. We'll pick up here, mathematic educator. I assumed you meant for keeping larger amounts of music, but might not have been what you were going for. Let's see. I don't know if I want to do that one. That's kind of gross. I'll write it out anyway. Nazuyama, how's it going? Yes, thank you for the lurk. Alright, suppose m is a constant and a natural number. Oop. Z plus then. Close enough. Then consider the following limit. You have the limit as n goes to infinity of 2 over n to the 3 plus m times the sum of the sum of the sum of, yes, you read that right, negative 1 raised to the m minus k times m choose k times I to the 2k plus 1 times j to the m minus k all over n to the k. And that's first. K goes from 0 to m. J goes from 1 to n. And I goes from 1 to n. Like I said, I don't know if I want to do that. Yeah, no, it doesn't really work for me so much, just because I can't, I mean, I could, but I don't want to play my music on stream, and, yeah, I've got 200 and some odd hours worth of actual music, whether that come from, CDs or digital downloads or whatever else. Yeah, there was a point at which I stopped like editing the metadata for all of my songs. I was just like, I can't standardize this anymore. And then at some point I was like, it really also doesn't help that like the information that it puts in the Winamp box that I had was saying like the band name, and in some cases like Bare Naked Ladies, it leaves about yay much room for the song title. It's very unhelpful. It really whips the llama's ass, yes. I had several of those that I just accumulated because they, like every new major release, they'd put out a new one of those. So I've got like 4, I think, at this point. They didn't really update the whole thing all that much. It was just little tiny updates. All right. Without looking at the answers, because the answers are actually there. Prove that limit exists, and that limit equals 0 under the condition that m is going to be, I'm using all the good Sure, we'll just do that. Alright, so 1, that's going to be that proof. And 2 is going to be find the limit when m is equal to 2016, which was the current year of this particular magazine. Nope, I lied. It's probably the current year of when it was written. This one's from 2018, but whenever the teacher did it, they probably found that there was at least a nice answer with 2016 and used it in 2016. Likely, anyway. Or show the limit does not exist. Okay. So, first thing, we're going to go in and change up the binomial theorem here to its expanded form that has factorials in it, which, you know, but at the same time, it makes sense that we do that. Get that limit, n goes to infinity of 2 divided by n to the 3 plus m is an odd number. So that means that the n to that power, whatever it's going to be, is going to be positive. We know that much at least. Although n's going to positive infinity, so we would have probably said that anyway. If m is an odd number. I'm wondering if that includes negative. Oh, don't start that. I think I need an institute nap time before stream. That's not, nope. I'm trying to copy it from the line above, that's not what it is. Alright, -1 raised to the m minus k times binomial here is going to be m of m choose k, so that's going to be m factorial over k factorial m minus k factorial. Multiply by I to the 2k plus 1 times j to the m minus k, all divided by n to the k. Okay, now we know that this thing here, 3 plus m, is going to be even because m is odd. Event. Sorry. Something caught my attention. Needed to just real quick work on that. Okay. What else do we have? So we know that 3 plus m is going to be even here. It's not really going to help overall because, again, n is going to go off toward infinity. And then m is any particular odd number. It doesn't matter how big it is. And n is going toward infinity. So our i's and our j's are going to go to infinity. This is even saying that the sums, iterated sums of all those things, is going to make all of this go to 0. But we're multiplying by something that is very quickly going to 0. So that seems to me to make a lot of sense. Got n to n, but m is a constant. Okay, so it's a high power, but it's not going to be humongous. Right, m is not going to infinity. N is. I's and j's are going off to infinity. They're in the numerators here. And k is only going as far as m. These are alternating signs. So let's look at just the first couple of terms. This is going to be horrible, but nonetheless. Nope. 2 over n to the 3 plus whatever m is going to be, we're just going to leave m. Okay, times I going from 1 to n. J going from 1 to n. Then here, we're going to have stuff that starts with a -1 to the m minus 0 times m factorial over k factorial is going to be 0 factorial is 1, and then m factorial. Okay, so that's just a 1 as well. Nothing much happens there. And we multiply by I to the first and j to the m all over n to the 0 is just going to be 1. Okay. Then plus, if k is 2, nope, if k is 1, we repeat all the same stuff. -1 raised to the m minus 1 times m factorial over 1 factorial and m minus 1. factorial times I to the third j to the m minus 1 over n, right? To the k is going to be 1 in this case. Okay, plus, I'm only just going to do probably like one more. Negative 1 to the m minus 2, m factorial over 2 factorial, m minus 2 factorial, times I to the fifth, j to the m minus 2, all over n squared, plus dot dot dot. And that ends at negative 1 to the m minus m, so that's going to be 0. Right. This is still m factorial divided by m factorial 0 factorial. Right, so in this case it's m minus m again in the second factorial, so that's going to clear that out. And then m factorial is our current k value that we're on. Alright, times I to the, this is 2m plus 1 times j to the 0, m minus m again, over n to the m. Particular case, right, m is going to be odd, which means that this is going to be negative, the next one's going to be positive. We'll actually have alternating. That's not fair, we're always going to have alternating signs, but we're going to start on an odd, which means that this particular term is going to be negative. Alright, so then we have a plus negative 1, m minus 1. This one's going to be even, so it's just going to be a positive, times m factorial over m minus 1 factorial is just going to be m. And then times I to the third, we'll just put a 1 there for good measure, times j to the m minus 1, and all over n. Plus negative 1, m minus 2, that one's going to be negative. M factorial divided by m minus 2 factorial is going to leave m and m minus 1. And then all over 2 factorial is just 2. Multiply by I to the fifth times j raised to the m minus 2 over n squared. Okay, plus dot dot dot. That's gone, it's all ones. We just get I to the 2m plus 1 all over n to the m. Okay, so why is all of this going to end up being summing to 0? So in the limit, we're still summing over both I and j. I don't see any nice way in which they just kind of like line up with some other value, unless we start talking about here we have a j to the 0. It's not entirely true. Okay, I was thinking maybe we could get this to say the stuff over here with I to the first and j to the m could then be echoed somewhere over here with j and m being reversed because the exponent on j is m minus k. Right? I was thinking somehow we could tie this in. I'm not sure that's true anymore, but whatever. If anybody does have any questions, we typically use the Discord server associated with Penn Center, and there is both a maths forum and a what else is there? Maths chat. So if you are interested in getting a question posted there, we can work on that. Or you can post something into Twitch chat and I'll get that too. Typically don't check Discord all that much, but hey, if you tell me that you put it over there, I'll notice. Alright, I'm gonna have a look here. Okay, so this thing went back ways and did not change out a bunch of stuff. Oh, wow, okay. That makes a lot of sense. Alright. Instead of messing around with all this stuff down here, the person who did it in the magazine said what we can do is 2 over into the 3 plus m I j. We can remove one of the i's here. M minus k, m, k, m choose k, and then here we've got I, not 2, I to the 2k times j to the m minus k. Decided to put together the -1 and the j because they both have the same exponent. Makes sense. so n choose k times I, this is n to the k at the bottom, I squared over n, this stuff raised to the k, and a negative j raised to the m minus k. Okay, they then said, oh, what do you know? This is just yet another binomial. So this being the formula of a binomial problem, we can then actually say that this is going to be the sum of, right, n choose k times I squared over n to the k times negative j raised to the m minus k. This is going to be I squared over n minus j raised to the, nth power, but in this particular case, right? What is it, actually? It's m. Alright, we don't have third one anymore. Okay, for the next bit. Okay, this is 2 over n to the 3 plus m can be n to the second power times n to the m plus 1. Not chosen arbitrarily. This is going to be 2 over n squared multiplied by, and this is n raised to the m plus 1. The only indices that are left are in I and j, and so we don't have any problems with n to the m plus 1 getting multiplied or thrown around all over the place. So here we're going to put this all the way at the end, and that's 1 over n to the m plus 1. 2 over n squared times the sums of I and j are indexed over I and j, and here we have again I multiplied by here. What we're going to do is split this up into 1 over n to the m times n to the first. We don't really have to. But then in order to get into the parenthetical that has an exponent of m, we need to give up that m. Hang on. We left 2 out there. We took m to the n to the m plus 1 with us. No, that'll work. Okay. Okay. This end of the first ends up on the outside here. Okay. And then moving in, we take the m off of our 1 over n. And that's going to get us I squared over n squared, right? 1 over n attached to all of the things that are here. So minus j over n. taking the limit of this whole thing as n goes to infinity. Okay, if the ends were to go in as well, make this 2 sum I and j of I times the quantity. Right? Oh, wait, no. Can't do that because there's an m there. Okay. I over n cubed. Now we want okay, that thing squared minus j over n. So as it stands for all of these terms, right, no matter what I and j are, if they are sufficiently small, if I and j are sufficiently small, then n gets really big and just overwhelms it. As I and j each start approaching infinity, okay, that's still m. Okay. Not even in that sense. These have the same degrees. So what happens is, no matter what outcome happens that comes out of those parentheses, that gets written onto whatever expansion of these sigma forms that we have, right, our I and n and j and n will always have, from that binomial, the exact same power all the way through this problem. It's whatever m is. Then when we multiply by the I over n cubed bit, these are unlike Alright, and since it's larger on the bottom, then we're going to say that I is going to be a smaller number, first of all, than whatever n is, or it's going to be equal to. If it's equal to, again, we get, n over n squared, which is just 1 over n, which then gives the edge to the denominator still, because now it's going to be still going to go in favor of the denominator having a larger piece, because I and j have to be no larger than n. So having unlike degrees at the beginning is then going to confer knew what I wanted to say. That is then going to confer an extra 2 degrees of n in the denominator. And so eventually this is going to go to 0. I would probably be satisfied with an explanation like that. However, okay, I is going to be less than or equal to n. And with the exponent cubed in the denominator, again, we're going to have, if they are in fact equal, it's 1 over n squared, and anything else, it's going to be a larger number in the denominator. Okay. Anybody have any questions? And in the the magazine version, this says, you know what we can do? This wants us to do a Riemann sum, which says that f of x, y, our function, is going to be equal to 2x times the quantity, x squared minus y squared. Nope, that's wrong. X squared minus y all to the m. Make sure I copied that right. Yep, alright, cool. Alright, so if we do a Riemann sum on this, we're looking at something in technically 3 dimensions. Oops. Oh. Oh, no. Okay. We're still good. Never mind. That's just pre-roll. Alright. Let's take a 3-minute break, and I'm gonna stand up and probably stretch a bit. And I will see you back here in 3 minutes. Be back soon. Thank you very much for sticking around, and let me know what questions you might have. Had my jeans on, couldn't stand it. So, opted for the shorts instead. Much better. I mean, look, it's only about 22 to 24 in here, but... Alright, so thanks for sticking around. I redeemed my own posture check. I need to get a couple more redeems in there and probably up the cost of some of them. Or at least some stretch like that should be at least like 1,000. Okay. So we've got all sorts of fun stuff that this could be here. Right, we have some sort of surface. I don't know what it looks like. It's probably not this, but I'm just exaggerating. So we want to do a Riemann sum for this, which is saying that we're going to be taking the function 2x times x squared minus y raised to the m, and all of that is the inside stuff. So 2 times x, where x is I over n. Right, and x is I over n. Y is j over n. That's going to be fun. Okay, this also means then that we're doing right, we're basically creating a whole bunch of blocks out of this. Whose height is going to be our f of xy, and whose width is going to be delta x, and whose length is going to be delta y, or however you want to say it. So we're getting volume, which is going to be equal to f of xy times delta x delta y. And if we assume, I think this is what this is saying here, yeah, we're going to do over surface 0, 1 by 0, 1. Then the way that we're doing this, delta x is going to be equal to b minus a is 1 minus 0 over n, times delta y is also b minus a in the y direction, d minus c, or whatever you want to call it, and that's 1 minus 0 over n as well, times our f of xy. Alright, so this is the individual v sub I. And yeah, technically we get like xi, yi. And so we'd need to sum this up in the x direction. Oh, x sub, yeah, it's ij. So we're summing up in the I direction, we're summing up in the J direction for this particular thing, and then that's going to be f of x sub I, y sub j, times 1 over n squared. Is going to be the approximation for all of these things, which is what we've got. And then when n goes to infinity, limit n goes to infinity of v sub a, whatever, then that's going to be equal to the true volume, which is the double integral from 0 to 1 in both directions of our function 2x times the quantity x squared minus y to the m dx dy. Or I guess they do it as a. That works. Okay, with multivariate calculus, what we're going to look at here is that the true volume is going to be equal to, we're going to take our dx first, that's the one on the inside. When we look at this, we're looking at doing a power rule, because here we have a constant exponent. Our derivative of the inside, if we let u be equal to x squared minus y, then partial u with respect to x is going to be equal to 2x, and that's all we got, 2x, plus 0, because our y is treated the same as a constant when we're trying to derive partially over x. So we have, or we could do it as like partial of u is equal to 2x partial of x. So we have that, it's just written in ordinary form rather than partial form. We're doing one at a time, so it's fine. So this is going to be going from 0 to 1 of, we have the du that's here, right? It's this and that together, so 2x delta, dx, and then it's a power rule, so we're taking the integral of something to the mth power, which means we're going to get 1 over m plus 1 multiplied by x squared minus y. It's fine. X squared minus y and dy. This is raised to the m plus 1. Alright, now we have to do the same with y and x, right, on x, this needs to go from 1 to 0, or 0 to 1. Alright, 1 minus y dy minus this where x is going to be 0. Negative y raised to the m plus 1. Alright, with this, we're going to take the inside here. Both of them have a du that is just -1. So we're going to flip the order of these things. So that's going to be a -1 over m plus 1 times the quantity negative y raised to the m plus 2. This is m plus 1. It's going to be multiplied again by m plus 2. Minus 1 over m plus 2 m plus 1. 1 minus y to the m plus 1, m plus 2. Okay, and then both of these are taken from 0 to 1. Okay, so this is going to be a -1 minus 0. So it's just going to be -1 to the m plus 2 minus 1 over m plus 2 m plus 1 times the quantity again here. This is going to be 1 gets us a 0 value, so that's gone, and then we would get a negative. Nope, we would just get a 1 value on the inside when we're subtracting. So this would be a 0 minus 1. That's not right. Can't do that. I mean, it's equivalent in this case, but we can't do it. Blue Danube, nice. Alright, so that's 0 to the m plus 2, which just wipes out this whole thing, and then minus 0 plugged in makes it 1 to the m plus 2. So it's still 1, doesn't actually change anything there. So this is equal to m plus 2 is also going to be odd if m is odd. This is going to be a plus 1 over m plus 2 m plus 1 plus 1 over, oh no, I messed up a sign. Arg. M plus 2 m plus 1. Alright, m plus 2, m plus 1 is supposed to be on the bottom. Good. And then there's a... There's a 1 and a negative 1 raised to the m plus 2. Okay, with x, we're not changing the signs at all. We just divide by our m plus 1 in each of these things. Then we end up with a 1 and the minus the case with the 0. Okay. And then on the next step, taking the integral with respect to y. I think it's on this step here. I think when I took this integral, let's see. We got 1 over m plus 1 times the quantity, 1 minus y, all raised to the m plus 1. Then minus 1 over m plus 1 times the quantity, negative y, raised to the m plus 1. I think I forgot my u substitution going between here and the next line. So I do think that this should be a positive value, and then that means that down here it becomes a negative value. Okay. I'm satisfied. I grant you that wasn't very satisfying. Feel free to go back and check my work, all that good stuff. Book also says if you go to this step and then take this on separate little journey over here, this is going to be 1 over m plus 2 m plus 1. Times negative y to the m plus 2 minus 1 minus y the m plus 2. Over m plus 2 m plus 1. Alright, a1 is going to get us a negative 1 parentheses m plus 2 minus 0. Okay, so that is what we get if we plug in 1. If we then plug in 0, we get minus 0 plus 1 raised to the m plus 2. Alright, this is always going to be equal to 1. Okay, so negative 1. When m is odd, this ends up being a negative 1 plus 1, which is 0. When it's even, it's going to be 2 divided by all that stuff. Okay. Gotta change tack, because yay. Yeah, sure. awesome. It's like being in Brother Sabathius' channel. Brother Sabathius is an Elite Dangerous streamer who, and other things, but that's, I think, his main partnership, who every so often has a redeem called Order 66, and it ends up playing some sort of like upbeat polka like this while he's wandering around murdering everybody at a particular site. Alright, so let's build this backwards. Jeez. Zach has been online for 11 hours. Not to say he hasn't taken any breaks, but still, the fact that he has been online for that long is quite impressive. Okay, so I think what we're going to do is go over and see Dawn. And I'm just going to go pass out because it's been one of those days already. Okay. So tomorrow, we're going to be using some of this stuff and what I was working on down here in order to fill out some more questions so that we can have that stuff for tomorrow's class. So tomorrow we do have a differential equations class. I am looking forward to seeing everybody there, and if there's anybody else who does want to join the actual class portion of it, then let me know through Penn Center's Discord. One more time for that. That's the Discord server that we're using. I'm going to change some of the commands and give myself some other random stuff so that I can maybe have a little more fun on here. So, hope you all have a good evening. We're going to go over and raid Don Does Math. And we'll see you tomorrow, hopefully for class. And then Friday we're going to do some more gaming. Pretty sure that's going to be like Breath of the Wild or something, so we'll see how it goes. Alright, see you all later. My name is Obi-Wan Pez. This is N Simplex Pachinko. Have a good night.